All right, and this is the part that we did not get to last time. Oh, sorry, in class. So here's the two exercise problems. They actually follow the homework problems very closely. So I want to show you this here. First things first, I believe we are in exercise number 5. So use definition 2 to find an expression for the area under the graph of, it should have been f of x as a limit. So here's my little function right here. A graph of f of x as a limit. Okay, so real quick here, definition 2, what in the world is that? So let's go back and find out what in the world is definition 2. Definition 2 says this. It's going to be the area underneath the curve is the limit as n goes to infinity of the right-hand side. So this is the extended version right here. And we usually don't write it this way. Right? This is f of x of 1 delta x plus the second point, same way, and then we go all the way out to n. Okay, boom. Okay, then the shortened version, right, is the limit as n goes to infinity. That's the one that we really want here. So n goes to infinity of the summation as I goes from 1 to n of f of x sub I. And that should be an I. And then it is that little piece right there. All right, so let's begin. So what the first thing we're going to do is find delta x. That's the first thing we want to do. That is going to be b minus a over n, because we're going to slice it n times. And here's our a, and here's our b, and we are good to go. So how about 10 minus 3 over n? It gets us a difference in x values of 7 over n. Perfecto. Okay, then we have another little formula. It says x sub I, so that the ith x value that gets plugged into the function is going to be a plus I delta x. Let's put it in. So all it means that that little a value comes from right over here. It's the start value that we begin with. And then all we do is we go nth times, right? There it is, just to make it a little nicer looking. How about 3 plus 7i over n? Okay, what we have to do here is we're going to have to plug it into the function. So that piece has to be plugged in into ln of that and x of that on the bottom. And there's our function that we need. So we're going to follow this here. So ln of n going to infinity. We're going to set up our markers to go to the right-hand side of things. We're going to plug in our values into our function and then a dx or delta x at the end. So a equals limit as n goes to infinity. And we got ourselves the right-hand side values. Limit as n goes to infinity of the summation from 1 to n. And here's our formula. You don't need to write this one down. That was just a formula from the previous slide. But this one is the one, final answer is limit as n goes to infinity. The summation of I going from 1 to n, and it is ln of our xith term, if we want, and then over x itself. All right, also multiplied by the delta x. There it is. So we have figured out a little pattern for us to follow. If we work this all out, we should be able to get to the area underneath the curve. Now, it does have an ln inside there, so it gets a little complicated, so that on the homework it says not to evaluate this. You're just sort of setting up the formula for evaluation. But in this case, you would be done at that point. All right, so that's example number 5. Again, similar to the homework that's in 5.1. Let's jam to example number, this would be 6. Let me make a little 6 right here. Okay, last one of the day. Example number 6. It says this: determine the region whose area is equal to the given limit. So it's going to go backwards. Really, we're going backwards now. So here's my function, whatever it is. And I need to figure out what function are we even talking about? That's the question. What function are we talking about that I'm trying to grab the area underneath that region? All right, so what I see possibly a delta x being right here because I see another delta x being right there. So that's the first thing I see. And again, I'm just trying to get the function out. So that means, in fact, you can even rewrite it if you like. You can say the limit as n goes to infinity, I goes from 1 to n. I could put the function in front. I put the delta x in the back. So at that point, then it's more like this. It's more like f of x sub I delta x, and delta x is given. So delta x just means we have a interval of 2 that's being set up. And then this little piece right here, that just means, it's a plus sign, sorry. Should be a plus sign right here. And this is just a plus I delta x. I think I have everything I need. So that means the interval that I'm having right here, interval is a length of 2, and my starting point is 5. Remember from the last point, whenever we go along, it's always this right here, right? You go from A to B. So A is my starting point, is 5, and I have an interval that goes to 2, so that means B have to be 7. If you want to be a little more precise, mathematically speaking, you would say that your delta x formula is B minus A over N. And you say from a problem here, 2 over N is the same thing as B minus 5 over N. N's are the same on the bottom. No need to solve those. So we're going to solve for that right here. So we're going to move the 5 over, and voila, 7 is equal to B. So what is my function? My function looks like is I'm taking something, this x value, to the 10th power. So y is equal to x to the 10th power from x is equal to 5 to x is equal to 7. Are we good? Does that make sense? Hopefully that does. All right, and if you got to that step, you are doing great. That's kind of as far as you need to go. Everything makes sense, and everything is processed correctly here. But I do want to say real quickly here that this answer is not unique. That means this could have been actually different functions. So let me go a little further. So again, for your homework purposes, if you got to this step, you're doing great. Just do it, and you're fine. But I want to go a little further, just for you guys to sort of see something here. It could be that this function was not x to the 10th. It could be that this function was, and let's kind of think about this together here. Maybe the function was this right here. So we were not moving from 5 to 7. It could have been that we just had an interval from 0 to 2. And I just want to see if this makes sense to you guys here. There it is. So notice what happens here is if the interval was from 0 to 2, then our delta x would have been 2 minus 0 over n. And notice it still gives me the exact same formula. Because if I were to plug in 0 for my a value, or x sub I value, if I were to plug in 0 plus, let me do it like this here. Let's see. It would have been just 2I over n, right? And as we plug it into the function, it it would have been 5 plus 2in, and then we just take it to the 10th. So notice these guys are still exactly the same. You've just replaced it. Oh, sorry, real quick, not that one. This value is the same as that value there. So these guys are not unique to, it could have been a different function, just depending what you want to add in into the function to make that true. Okay, that was just an extra aside. If you got that and understood it, that was great. But as long as you got to at least to this part right here, it's great. Okay, I'm done, and hopefully that'll give you enough information to do 5.1. If you have any questions, we will, of course, gather together on Friday to take a look at it. And have a great day.